So last week we were really working on the order of operations and solving for what we would call numerical expressions. And numerical meaning they have numbers. So if we write that right underneath here, numerical expressions, those are numbers. So for example, 2 plus 3 times 4. That's a numerical expression because it's all made up of numbers. Well, now we're going to start to look at algebraic expressions. So you can see the word algebra in there. And when you think algebra, you should think x or variables. So we want to show that this has variables. And variables are your x or whatever letter that represents a letter. A number. It's a letter that represents a number. So for instance, 3x plus 2 is an algebraic expression. Because yes, there's numbers, but there's variables. Okay, and eventually we're going to learn to solve for those variables. But for today, we really want to start learning what these variables mean. What does it look like when things are being multiplied or divided with a variable? So that we're going to start solving for algebraic expressions, we got to know what it says first before we can actually solve for it. So that's what we're going to work on today. So a couple key terms that we're going to need to know: the sum, the difference, the product, the quotient, things we've talked about before, things you've talked about in prior years. Just want to double check, make sure we've got all that. So the sum is your answer to an addition problem. So for instance, the sum of 5 and 2 is 7. The answer to 5 plus 2, the sum, is 7. So it's the answer after addition. So this is going to be the same thing, except the difference between two numbers is the answer to a subtraction problem. So when I ask you what's the difference between 100 and 95, you say 5. Well, what'd you do? You subtracted the answer or the difference of subtraction. So the product is multiplication. So this is the answer to a multiplication problem. And that leaves division. So quotient, that one we don't use as much. We use a lot of sum, difference, and product. But quotient, we do need to know it. We don't use it as much, but we need to know it is the answer to a division problem. So we've got addition is sum, subtraction is difference, multiplication is product, and division is quotient. So what we're going to do here is we're going to translate some sentences that are written out in words and turn them into algebraic expressions. So we want to represent 5 times a number. Now notice it doesn't say 5 times 6 or 5 times 7. It's 5 times a number. We don't know what the number is. So every time you see the words a number, you need to think x. So when you see a number, the word, you need to think of a letter, which at first seems a little backwards. But x is the most common variable we're going to use. But it can be any letter that you want. It doesn't have to be x. But it stands in the place of the number that's missing, and we don't know what that number is, so we're going to fill that spot with an x. So 5 times a number. So you might say 5 times x, like this. Nothing wrong with that, technically correct. You could use parentheses. We learned that when there's parentheses next to each other, that's multiplication, right? So this says the same thing, 5 times a number. But what we want it to look like is just 5x. That's what you're going to see. If you look down, there's 3x. Okay, that's what you're going to see. So we need to know that if a number and a variable are just connected like this, that's multiplication. We must know that. So again, x is your variable. Variable is your letter representing a number. And And the number that's attached in front has a special name, and it's called a coefficient. Kind of a long word. We're going to use it a lot. So the whole number that's attached or being multiplied by this number that we don't know, so it's represented by a variable, the number is the coefficient and the x is the variable, or any letter that you want to put in there is the variable. All right, so what if we want to show division? Now you could write a number, remember that's x, divided by 8. So there's nothing wrong with writing x divided by 8, but we're not going to really use that division symbol much anymore. We've talked about what that's going to look like from now on. Division is written in fraction form, so it's going to be x over 8. And this is what multiplication is going to look like, 5x. Okay, we've looked at that. So now, 3 less than a number. The most common mistake people are going to put on this one, it's a little tricky, is they're going to say 3. They're going to see less than, they write minus. And then they see a number and they're going to write x. So they're going to say 3 minus x. But that's a number, that's 3 subtracted by a number. And that's not really what this says. This is 3 less than a number. So we're starting at a number and we're taking 3 less than it. So if I said, what's 3 less than 100? You'd say 97. Technically, what did you do? You took 100, which was the number, and you subtracted 3 from it. So this is a little backwards. The English doesn't match the algebra. So 3 less than a number, you take the number first. And you're taking 3 less than it. You're subtracting 3. So be careful. If you write this backwards, it's not technically correct. Because let's say this was 6. 6 minus 3 is different than 3 minus 6, right? You're going to get the negative version. So we do need to be very careful with that one. So let's try this one. 2 times a number plus 3. So 2 times a number, we're going to show that as a coefficient and a variable attached. That's multiplication. We don't have to write times. We don't have to show a symbol. If they're attached, it's multiplication plus 3. This is a whole expression. Now, this next one, 2 times the quantity x plus 3. We have the 2 times. We've got the x plus 3, but this is different because it's 2 times the quantity x plus 3. Okay, quantity means total value. So we're going to multiply 2 times the total value of some number plus 3, which means we're going to add this x and the 3 together, and that total value, we're going to take 2 times that. This said something different up here. This was just 2 times the number first, and then add 3. Whereas this, we're going to add x plus 3, get the quantity or the total value, and then multiply that by 2. So we need something that represents this happening first. Well, how do we show something's going to happen first? We use parentheses. So the x plus 3 needs to be in parentheses, telling us that this must happen first. And we're multiplying this whole quantity, or the parentheses, by 2. Now notice again, I didn't put a multiplication sign. You can put the 2 right next to the parentheses. If it's right next to a variable, or right next to parentheses, or parentheses are next to parentheses, it's multiplication. Okay, so it's one of the special ones. We don't have to write anything fancy. We literally just put them next to each other and we know it's multiplication. All right. We're going to add a little word to these next ones. The word is. So a number divided by 4 is 3. So if I take a number, I divide it by 4, it is, or equals, 3. So we're going to add an equal sign where we say see is. So first of all, it says a number divided by 4. So that's x divided by 4. A number divided by 4 is equals 3. This is no longer an expression. This is called an equation. Okay? You see the word equals almost in this word equation. So as soon as you add an equal sign, it's no longer an expression. An expression is just like a sentence with no equal sign. An equation adds the equal sign. So those words are kind of similar. Okay, we need to know the difference between the two though. Expression, no equal sign. Equation has an equal sign. So the last one, 8 less than a number is 10. So we know it's going to say equals 10. Be careful, it's 8 less than a number. So you have the number and you're taking 8 less than it. So it's x minus 8. You can't have it backwards. It's x minus 8. All right, so now we're going to try and go the other direction. We're not going to do all of these, just a couple of them. So what does this say? Based on what we just did, what does this say? So it's 3, and then what's happening with the x? Well, we talked about if they're attached, the coefficient and the variable, that's multiplication. So this says 3 times a number. We don't know what that number is, so x is a number minus 4. And you could have wrote this differently. There's more than one way to write it. You could have said the product of 3 and a number, right? Product is the answer to multiplication. So instead of saying 3 times, you could have said the product of 3 and a number. And instead of saying minus 4, you could have said subtracted by 4. You also could have said 4 less than 3 times a number. So there's more than one way to write these out. And they're still correct. Now number 10, again, looks similar, kind of like we did up here. Except we know if we're going to solve this, if we know what x is, we have to do the inside of parentheses first, and then times it by 3. So we can't just say 3 times x minus 4. That's what this is. This is different. So we're still going to take the number 3, and we're still going to multiply it. But we got to use a special word with parentheses, quantity. So 3 times the quantity, x plus 3. And you could have said a number plus 3 or something like that, or the sum of a number plus 3. Lots of ways to say it. So this one, we can say a number minus 5 is 2, or we could say 5 less than a number. We took the number, we're taking 5 less than a number. And now we got that equal sign, is 2. You could have said equals as well, you don't have to say is. So let's try that one here. So this is x, which is a number. Fraction is division, so a number divided by 4. Now let's try it the other way. Instead of saying is, you can say equals, just like you're used to saying, 3. But we just need to know that this is the same thing, is and equals. And these two are going to be very similar. So let's just skip to the bottom. A couple fancy ones here. Let's make sure we can handle them. Twice a number decreased by 5 is 19. What does the algebraic equation or expression, in this case it's an equation because there's an equal sign, what does it look like? So when we take twice a number, we're doubling it. What does that look like? How do you do it? Well, you multiply by 2. So this is just multiplying some number by 2, then decreasing it by 5, and that has to equal 19. So 2 times a number is 2x. Remember, we don't show the multiplication, they're just attached. Decreased by 5 minus 5 is 19. Last one, half of a number plus 10 equals 16. I'm going to give you a second to think about this. How do we take half of a number? What is that going to look like? You try it. Half of a number. How do you take half of a number? If I said, what's half of 10? It's 5. How did you get there? You didn't subtract 5. You probably divided by 2. You take half of 20 and you get 10. You're taking 20 and dividing by 2. So to take half of a number, you're actually taking the number divided by 2. Plus 10 equals 16. There's other ways to take a half. Let's think about it. What can we multiply x by to take a half? Well, a half is equal to 0.5. So if I took 0.5 and times it by x, that's the same as taking a half. I get the same result. Dividing by 2, I get half. Multiplying by 0.5, I also get half. So plus 10 equals 16. There's another way you could write this. We're still going to multiply by a half, but instead of expressing it as a decimal, you can do a fraction. So 1/2 times x, that's what this says, plus 10 equals 16. So 3 different ways to write this algebraically. So for a lot of these, there's more than one correct answer. All of these are good. All right, you're going to try some classwork on this? Just raise your hand and I will get you that classwork.